This is the third of 3 parts on significant figures. So the first part looked at correctly recording, second part looked at counting significant figures, and this third part looks at how we use significant figures in calculations. So the first thing that's important to note with significant figures in calculations is rounding them correctly. So there's 3 rules, but often we use just the first 2 depending on what we're doing. So the first rule is if the number following the digit to be rounded is less than 5, we drop the remaining digits and replace them with zeros. Some people refer to this as rounding down. The second rule is if it's greater than 5, we add 1 to the digit and then drop the remaining digits, sometimes referred to as rounding up. Some people use this rule for 5 and greater, in which case they don't use the third rule. However, if you are dealing with large series of numbers, it is good to use what's called the odd-even rule, which says that if the number following the digit to be rounded is exactly 5, we keep the digit as is if it's already even, we add 1 if it's odd, and drop the remaining digits. So the odd-even rule does not get implied in all textbooks. And in fact, because it has to be exactly 5 with all zeros after it, it doesn't come up very often. So I'm going to give some examples, and I will show one that we could do using that odd-even rule or not. So if we're looking at rounding each of these to 3 significant figures, our first one here, 123.40, the 1, the 2, and the 3 are our 3 significant digits. So we look at what follows the 3 is a 4. So that's less than 5. We would keep the 3 as is and drop the rest of the digits. And because we want to show it to 3 significant figures, we don't put any decimal places there, right? We're just dropping them. We don't need placeholders in this particular case. Second example, our first 3 digits is the 5, the 3, and the 8. It's followed by a 5. So if we're doing the 5 and up, we round up rule, we would just say 539 and replace the remaining things with zeros. We do need the zeros this time because they're placeholders. If we're using the odd-even rule, we would keep the 538 because it's already even, right? We keep the 8 as is. Next one, if we're rounding to 3 significant digits, our third digit is the 10th place here. So it's followed by a 7. We would round up to 10.1 liters. Third digit here is the 5, followed by exactly a 5. So it's another one that the odd-even rule applies. But because it's odd, the odd-even rule says round it up. So whether we use the odd-even rule or not, we're going to round this one to 0.0360 liters. Third digit here is the 6. It's followed by a 5, but the odd-even rule does not apply because it's more than 5, right? It's not 500, it's 534. So it's greater than 5. We round that 6 up to a 7. Don't forget to put in those placeholder zeros. Last one already is 3 significant digits. So if you have something that's 3 significant digits and you want to keep 3 significant digits, you just keep it as is. So we use these when we are doing different operations like adding, subtracting, multiplying, and dividing. We're going to tackle multiplication and division first. Most people find these a little easier. So our number of significant figures is equal to the smallest number of significant figures in the number being multiplied or divided. So if we have something like 2 meters multiplied by pi, 2 meters has 3 significant figures. Pi has infinite significant figures, and use the pi button on your calculator. Don't type in 3.14 because that only got 3. Your calculator can do way more than that. So we multiply that and we get to 3 significant figures when we round it 6.28 meters. $200 with the line on top. Remember that line tells us we have 3 significant figures divided by 3.0 seconds. That is going to be 2 significant figures pay attention to what you do with your units, right? If you have different units and you're using division, your units also get divided. So meters divided by seconds gives us meters per second. And we only keep 2 significant figures. So this really works out to 66.6 repeating when we type that in our calculators, but we round it to 67 meters per second. We can also do more complex calculations, like this one, where you have more than one thing being multiplied or divided. So then you got to look at all of them. So we've got 2 sig figs in our first number, 3 sig figs in our second number, 3 sig figs in our number that we're dividing by. So when we look at our units here, when we look at our sig figs, our least number of sig figs is 2. When we look at our units, that's actually a little more complex. For our units here, we're going to end up, the moles cancels the moles, the coulombs cancels the coulombs. We end up with per second in the denominator. So if we're dividing by per second, that's the same as multiplying by seconds. So we end up with just seconds for our units there. Adding and subtracting, we line up the numbers that are being added, subtracted, so the decimal place is in line for all the numbers. And when we're rounding, we go by precision with adding and subtracting, which means that our first digit that was non-significant in any number in the column is going to be non-significant. So if we look at the numbers as written, first thing we want to do is line them up. I see it didn't for this first one. Pretty straightforward for the first one though, because we have 2 decimals and 3 decimals, so the least number of decimals here is going to be 2 decimals, so we round to 2 decimals. So we don't count sig figs, we count placeholders, right? So this one's precise to the nearest hundredth, this one's precise to the nearest thousandth, the least precise is hundredths, which is why we round to hundredths. Next one, same idea. This one's precise to the nearest ones. This one's only precise to the nearest thousand. So when we line these up, we're going to round that as precise to the nearest thousand. When we're adding and subtracting, we do have to have the same units. I forgot units in my original question here. Right, those would have been grams to end up with grams. So we can only add or subtract if our units are the same. Gets a little trickier when we are looking at things that are in scientific notation. So when they're in scientific notation, we need to get them to the same power of 10. So with our powers of 10, we will often temporarily make it so that they're not the same power of 10. So in this case, I made them both 10 to the 5. So this number was already 10 to the 5. So to make this number 10 to the 5, my power of 10 went down from 10 to the 6 to 10 to the 5. In other words, it got 10 times less. But this is all one big number. So if I make one part of the number 10 times less, I can counterbalance that by making the other part of the number 10 times more. So as one goes up, the other goes down. So this becomes 45.39. Then I can subtract them as I normally would, and I can see 2 decimals in that top number when it's written times 10 to the 5, 2 decimals in the bottom number when it's written as 10 to the 5. So when I round, I know I can keep 2 decimals. Now it's not in scientific notation because I didn't choose wisely. So I still have to do another step, which is put that back in scientific notation. So I've got to move my decimal place over, so there's only one digit in front of the decimal, so it's getting 10 times smaller, so my power of 10 has to get 10 times bigger. Likewise with my next one, when I want to line it up, if I keep 10 to the minus 3 for both of them, I have to be careful. 10 to the minus 2 and 10 to the minus 3, we're in the negative side, right? So if I'm going down to minus 3, that's a smaller number than minus 2. So my front number's got to get 10 times bigger. So that's why I ended up with 28 here. So adding these up, we get 32.174. My first number had 3 decimals. My second number had 2 decimals. So when I round this, I only want to keep 2 decimals, right? That 7 is my last significant digit. So I want to change that. And I also want to change it into scientific notation. So this time I'm going to do the rounding and the scientific notation as one step. So what follows my 7 is a 4. So I'm going to keep the 7. If I'm moving my decimal place over to make this 3.2, that's getting smaller. So my 10 to the minus 3 has to get larger, and minus 2 is larger than minus 3. My next one, I showed a little more than I meant here. My next one is small enough powers of 10. You might actually choose on a question like this just to take it right out of scientific notation, especially since one number is in scientific notation and the other number is not. So if we take it out of scientific notation, we see they're both 2 decimal places, right? And we've got these zeros here because they are significant. So when I round it, I'm going to keep 2 decimal places. If you are doing multi-step calculations, you need to keep track of the significant figures at each step, but we only round once. So although we're keeping track, we don't round till the very end. So our first step, right, we do the multiplication inside the brackets. And we can see that's 3 significant figures times 3 significant figures. So it's still 3 significant figures, didn't have to do any rounding, even if I was rounding on individual steps. Then we do the subtraction inside our brackets. So I've got 2 decimals and 3 decimals. So when I do my subtraction, I'm going to round mentally, right, because I'm not rounding till the very end, to 2 decimals. So you'll notice I'm highlighting the 5 because that's my last significant figure. So I have 0.554 times 5. So I've got 2 significant figures times 3 significant figures. I'm going to be using my multiplication rule, which is the least number of significant figures, right? In this step, I was using my addition and subtraction rule, least number of decimals. This step, I'm using my least number of significant figures, remembering that highlighted point tells me where my last sig fig is. So when I round that, it's only going to round to 2 significant figures, which is 2.8. So there's our breakdown briefly on how we do operations and rounding with significant figures.